Welcome back to Physics Online. We are going to talk about free body diagrams. Let me go ahead and switch screens here. So to figure out if forces are balanced or unbalanced, physicists will use a simple visual tool called a free body diagram. Now, a free body diagram can be a box, it can be a dot. It doesn't have to be the actual thing, right? So instead of drawing a complex picture, we'll draw a very simple one. All right, let's look at this. So let's talk about each of these. So if this box is moving in, let me make sure I'm drawing here, is moving in this direction. And as a matter of fact, it will be moving in this direction and it should be accelerating in this direction. How do we know that? So the length of this line, the push, is longer. Now the push is actually taking place back here, okay? So we're going from the center, the push is applied this way because that's the direction that the force is applied, right? So we don't ever want like the push, we don't want that being drawn into the box. That's not what we want. So that's a nope, we don't want to do it that way. We always want it going from the center of the box to in the direction that the push is applied. Also, the length of the arrow indicates its force, okay? So we can see that this force here, from there to there, is longer from here to here. Since this is friction pulling it towards the left, and our push is pushing it towards the right, this is going to be accelerating. When they are balanced, when they're in their same length, if it's already moving, it's going to continue to move because of inertia, okay? But it's not going to accelerate. If one is longer than the other, that means that we're going to be accelerating in that. Now we could have a longer friction, and that would indicate that the box is slowing down. Now, I'm going to sneeze, so I'm going to go ahead and pause the video for a second. Hold. I just woke up the neighbors with that sneeze. Okay, so I want to talk about two forces here. Weight. Weight is the amount of force being pushed down by gravity. Force is equal to mass times acceleration, right? And so the box has a mass, and gravity has an acceleration, so there's going to be a downward force. And that's always taking place. I'm sitting in this chair right now. I'm not moving down, but there's a force pushing down on me. That means because I'm not moving down, that means there's got to be a force pushing back on me, or else I'd be accelerating downwards. They have to be balanced. Now, this is always, whenever we're talking about a force diagram like this, we're talking about one object. We're not talking about multiple objects, okay? That force that is pushing backwards is called the normal force, okay? And that is the table. When I take my mouse here and I set it on the table, it stays because the table is applying a force upward equal and opposite to the force that the mouse is exerting on the table. Now, can I exert enough of a force to overcome the normal force? Sure. If in my force diagram the weight is much larger than the normal force, I'll crush the table, right? And when I crush the table, that normal force for a minute is overcome, right? Until it hits the floor or the ground or whatever, right? So normal force is that force being applied backwards or upwards against gravity, okay? If you have any questions, jump in on office hours or send me an email. I'm so glad you're here today. Let's go ahead and let's continue on. Have a great one.